Scientists Unlock the Mystery and Evolution of Pitchers by James Gorman. No one knows whether Homo erectus, the early ancestor of both the Yankees and the Red Sox, threw a split-finger fastball. But he could have, according to a group of scientists who offer new evidence that the classic overhand throw used by baseball players at all positions, and a snowball, rock and tomato hurlers of all ages, is an evolutionary adaptation dependent on several changes in anatomy. They first appeared, the researchers say, around 1.8 million years ago, when humans were most likely beginning to hunt big game and needed to throw sharp objects hard and fast. No other primate shows with anything comparable to human force. Chimpanzees, who are much, much stronger pound for pound than human beings, can throw, as any zoo visitor knows, but the best an adult male can do is about 20 miles per hour. A 12-year-old human pitcher can easily throw 3 times that fast. Clearly, the reason is not muscle strength, according to Neil Roach of George Washington University, first author of a report in the journal Nature released on Wednesday. Dr. Roach, who conducted the research as a graduate student at Harvard, and his colleagues there used motion capture video to analyze the throwing motion of 20 college athletes who hurled baseballs at a target about 100 feet away, with and without a brace that restricted shoulder motion. They analyzed the structure of the shoulder and upper arm, the motion and the forces involved, and concluded, first, that muscles alone cannot account for how hard and fast humans throw. The shoulder and arm and the rest of the body involved in the throwing motion must be storing elastic energy, like the long tendon of a kangaroo when it hops, or the human Achilles tendon in running and jumping, they said. You're storing energy in your shoulder, Dr. Roach said, speaking from Africa, where he was heading to Lake Turkana to look at fossil footprints of human ancestors about 1.5 million years old. The storage occurs in the cocking motion. When a thrower brings the hand and ball back, preparing to throw, it works just like a slingshot would. You're actually stretching the ligaments. Several developments in anatomy allowed humans to throw this way, he said, including a waist that allows twisting and a relatively open shoulder compared with those of other primates like chimpanzees. Looking at the fossil record, Dr. Roach and colleagues put the moment at which these changes came together in one body at about 1.8 million years ago, when Homo erectus first appeared. It's possible that Homo erectus could throw as fast as we do, Dr. Roach said. What objects he threw is an open question. The most likely are rocks or some sharp projectile in hunting, Dr. Roach said. Homo sapiens, the species that would eventually form both the American and National Leagues, did not appear until about 200,000 years ago, and did not evolve the intellectual power and wisdom to invent the rules of baseball until the 19th century. The ideas that humans' throwing ability is unique and that it was important in human evolution and related to hunting are as old as Darwin. And pitching coaches and experts in sports medicine have long analyzed the details of the throwing motion, which is used in a number of sports. What is new in Dr. Roach's study, says anatomists, is the idea of the shoulders functioning like a slingshot and tying the specific anatomical changes to the fossil record. I think it's really a great paper, said David Carrier, a biologist at the University of Utah who studies biomechanics and its role in the evolution of hominins and other vertebrates. He said the paper provided a strong biomechanical basis to say we're specialized for throwing. Susan Larson, an anatomist at Stony Brook University School of Medicine who studies human and primate evolution, said the idea that the cocking motion stores energy was a very novel interpretation. This kind of energy storage, like the stretching a rubber band and then releasing it, is well known in animals and in human anatomy. But there is almost always some kind of long tendon that serves the function of the rubber band, she said. There are no cord-like tendons that make it a likely place to store energy. In the shoulder and the rest of the body involved in overhand throwing, she said, I can't say I can find any fault with the study, she said, referring to the analysis of energy involved in throwing. But I keep thinking, where are we storing this? Dr. Larson did disagree, however, on the throwing ability of Homo erectus. That's where Neil and I part ways, she said, referring to Dr. Roach. I don't believe that Homo erectus had the broad shoulders that would have given him the ability to throw the way humans do. Neanderthals, she said, probably did, and perhaps the common ancestor of humans and Neanderthals, putting the evolution of human-like throwing ability at some time hundreds of thousands of years ago, not 1.8 million. Throwing overhand, she said, is clearly an innate human ability, but not one that everyone uses. I throw like a girl, she said, hastening to point out that many girls and women throw hard and fast with the classic cocked arm, sideways body turned, and forward step of the overhand throw. There are no anatomical differences in the sexes other than the obvious size and strength that would make women less proficient at throwing. Dr. Carrier said he also thought the overhand throw was an innate human behavior. It's like walking, he said. You have to practice. Everyone who is able practices walking, but not everyone practices throwing. My daughter and son are formidable competitors in water balloon fights, Dr. Carrier said. Using the overhand throw, a technique they learn on their own in the heat of a sibling combat. In contrast, he said, some things require teaching. His children, like others, required years of coaching to be effective at swimming. If it is so natural, then why do pitchers have such problems with their shoulders? Not because throwing is natural, said Glenn Fiesig, research director of American Sports Medicine Institute in Birmingham, Alabama, and a specialist in pitching mechanics. What's not natural is throwing 100 pitches from a mound every fifth day, he said. That amount of throwing at that intensity is not natural.